Hello my friends, my name is Pedro Matos. I'm a Central Washington University master's student and I'm currently working on my thesis here in South Central Chile. And what we're trying to do here is study the tsunami deposits and understand the risk of these tsunamis in this particular location. But let me briefly explain you the geomorphology of our location. So we're here in Queule, and to the right we have the Pacific Ocean, and just like in Cascadia, we have a subduction zone offshore. And this area, you can imagine here the tsunami coming in from the Pacific Ocean, and the tsunami will grab the sand from the beach and from the dunes that we have right here in front of us. It's right where the vegetation is currently the highest. Right there, it's a very sandy environment. So the tsunami comes and grabs the sand from the beach and from the dunes and they spread out into the coastal plain. What that does is to leave a layer of sand in a place where there is not typically coarse sand sediments. So you would have very fine sediment below, or very organic sediments made by the wetlands and the typical estuarine environment that we have here in the coastal plain of Queule. And we would have a easy layer to differentiate between the tsunami sand layer and the soils below. So what we want to do is go to the coastal plains, which our site is right there by the barns, and we go and dig and make a pit, and we dig trenches and do cores to see what's below, what layers in the stratigraphy will be found below. And we typically can find different sand layers that were brought by tsunamis in the past. But first, let's locate ourselves. This is North America, and we have to go to South Central Chile, right here. And as you can see here, there is the subduction zone right in this section here, where it's marking the boundary between the Nazca Oceanic Plate and the South American Continental Plate. What is happening here is that the Nazca Oceanic Plate is subducting beneath the South American Plate here, and this causes, as you can imagine, a lot of energy accumulation in this area, which, when it gets released by earthquakes, it displaces the seafloor in this area, and that's what causes a tsunami wave and the perturbation of the water, and then the wave will propagate into the Pacific Ocean and into the Chilean coastlines. Here is Queule, and now that we know this, let's go to the beach. Alright, so here we are in the beach. Let's go quickly dig into the sand and see what kind of sand do we have, which will be the same as, or very similar to the 1960 tsunami deposits, which was quite recent, right? So here we are. You can grab a little bit of this sand. And the sand, as you can see, is very dark. It's fine to medium-sized sand and a lot of lithic fragments with and magnetite. It's really dark, as you can see. This similar sand, we're gonna find it in the tsunami deposit. So let's go over there quickly to just watch it. All right, here we are in the coastal plain. We can see right there on the background, you see the line of pines. Right, but that vegetation is right on top of the dunes, and that's the dune that has the sand that will be transported by the tsunami when it overtops the dunes, and it deposits the sand all over this plain. So let's go over there into the forest, where there is a ditch where we can see and observe really well the tsunami sand deposits and the sands that have been deposited below in previous times. Let's go. So here we are actually in the pit. So you can see here the soil, the thick soil in the forest right here. You can see the topsoil right here, really organic, and you can see this clean sand, which is the tsunami deposit. And as you can see, it has very similar characteristics as the sand that we found in the beach. Medium size, you have it's very clean. You have a very sharp contact below. It's like an erosional contact, and you can see that it's very similar. We can see also here these sorts of different features. This is burrows made by roots, the thick roots from the forests, and also by different kinds of shrimp that live in this area. Here we can also count. This is the 1960, above of the 1960 soil. And then here we have another tsunami sand layer. You can see that it's less thick than the 1960, and it has also sharp contact below. So here we have two tsunami sand layers that have happened here in the past. We know that this is then from the 1960, and then we have another one from the past that haven't been documented in historical documents. That's why this is very valuable. This kind of study is really valuable for us. But there you go, tsunami deposits.